Our first speaker, I'll do that at the end. Our first speaker is Tom. Tom is the founder and CEO of Raiven AI, a startup focused on making innovation responsible and accessible and impactful. Tom has worked with numerous large clients on data science and completed, he has an MSc in artificial intelligence from Utrecht University, very impressive. And he has a particular research focus in knowledge engineering and recommendation systems. And without further ado, Tom, if you would like to take the stage. This is quite scary when you hold it, by the way. Hope,
it's all quite scary. But first up, I guess, for us is to do a little introduction to who we are. So Raiven is formed a year ago, really close. We formed a year ago as basically passionate by we label ourselves that really because for us, we're really passionate about seeing people make effective, meaningful change in their innovation rather than watching as watching before we've been involved in it. So, I mean, online start by building. So this is
Am I covering? Is that the mic through?
Maybe it could be.
Is that better now? That's better now. Good. Right. So we get back to where we were. So let's assume now that, well, great, we're not scared by that investment. We believe we've got a great product. We're going to keep it in our centralized place. We're going to invest that money in and scale with the opportunity. Okay, great. Ooh, that doesn't look so good, does it? All of a sudden, your cloud's a bit stormy. You're servicing quite a lot of data from a lot of different organizations. In general, your users are fairly happy, or a couple of people, not at least concerned enough to make major complaints, except for maybe a couple, but you think it's fine. But you maybe put in a little garbage bin to deal with the pipeline a bit. You're starting to get a bit more mess on your server, but you think, right, really now, how much more are you going to try and scale this? And well, people do. So people do, and really, I guess it's only coming to one situation. Oh, suddenly you scale it to the point where you're trying to process so much data, service so many requests. What do you do with it? Your pipeline's starting to fall apart. I mean, this is maybe a little bit contrived to some extent, but really it's representing at some point something falls down, whether that's the funding, whether that's the complexity of the problem. Something's got to give when you're trying. You can't push everything through such a single pipeline without expecting something to fail, basically. And if it does fail, where is your backup? There's no sort of resiliency there, which brings us back to the problem, really. Wouldn't it be nice if we looked at this problem, if we were to think about it a bit differently? So, I mean, we've got large amount of data volumes, large amount of device volume, and people want data privacy. But maybe we're thinking about it the wrong way. How do we scale centralization to deal with those problems? Maybe the answer is in that problem itself. People want data privacy. So why transfer the data? Hang on a minute. Our device volume, there's a lot of devices. Isn't that going to suddenly make things a little bit easier? Well, that's sort of where federated learning comes in, because when we're talking about large data volumes are a problem when you're trying to put them through one pipeline. But if you were to spread that pipeline across multiple devices, suddenly that's less of an issue. So really, the process of federated learning is it's about parallel models by design, parallel and distributed by design. So suddenly your pipeline is now distributed to devices. They can run on the device. You take the data on the device, it never leaves the device. You have no issue about data privacy. You have no issue transferring a large amount of data because it stays on the device. You have no issue about serving a large volume of requests because it's all on the device. The only thing that you're serving back is updates to your model. And it doesn't have to stop at just one level. There are use cases where you may want to aggregate it at multiple levels. So for example, you might be a retail chain. You might want to serve recommendations to people based on an individual shop, but you also might want to know what is going on in the region around it. But on top of that, you want to keep it grounded on a global scale as well. Suddenly you can add in these extra nodes, the local one, the individual shop one, the local one, the global one, and you're able to aggregate on different levels, which sort of leads us to the main point of our use case. So why does it have to be just one organization? So let's sort of paint a picture. If you're an organization who, in this case, let's say has a health and safety use case, I mean, your use case is not specific to you. Like you have an organization B who is doing similar things. Maybe you've tried to tackle this problem with machine learning yourself, but with the amount of data you have, the level of accuracy you can get is about as much as saying, oh, we think there's going to be an accident in a fairly long time scale somewhere in London. You might have 3 sites in London. You go and tell a health and safety head that. What are they going to do about it? So where the magic really happens is being able to get this compute, this inference down to an individual site basis, but then collaborating with other organizations that have similar use cases as well. Suddenly your data volume, your training data, it's no longer an issue. The health and safety events are rare in one organization. When you consider it globally, you start to have enough to train models that can prevent these accidents from happening. But also, and critically for industry here, it doesn't matter to you if organization B is a big competitor to you, because none of your data is leaving your site at all. It doesn't matter if on your site you have personal data where there's regulations that might mean you can't push it up your organization, because it all stays on your site. Suddenly, a lot of the complications we were talking about earlier have completely disappeared. But what's the catch, I guess? I mean, it all sounds nice and easy, but there's got to be some complications, right? Otherwise, well, why isn't everyone using it? And I mean, one of the catches is that it's a relatively new technology. 2017, I believe, was the Google published the first paper around it, and it was to do with well, you probably all use it actually, ironically, on your phone. It's your Google keyboard, but that means that there is very limited use cases to study, particularly in industry. So what are we going to do when we're faced with deploying it? And the first one is, well, it's data science with a blindfold. So obviously the philosophy of federated learning is data protection, data privacy. So if you are a data scientist, that means really you shouldn't see any of the data. So how do you build a model without seeing any of the data? And I mean, the good news is that maybe we can work quite a lot with statistics about the data, distributions, variables, ranges. That can get us a fair way to understanding it. But this is an open problem as well. Like how far can this get us? And that's for us to explore in this project a bit. Alongside that, we've got the problem of fine tuning versus a good generalized global model. Like, it's all very well and good that you might want to tune to a specific site, but that you also want your models to not be hallucinating, to not be overfitted. So what is the right balance? And for each use case, this might vary as well. Again, this is an outcome to be determined by our project. And I guess on the industry side, one of the more interesting parts of this is well, one of the more potentially positive, transformative changes of this is we have to find a new standard. So for health and safety incidents at the moment, it might be that organization A and B that we talked about earlier have two different frameworks for reporting health and safety incidents. They might be similar, but there are some fundamental differences. In order for them to collaborate and cooperate, we need to find a new standard so they're talking the same language. So this model is able to help them and give them sort of results that they can actually take action on. So, and then the final one is obviously collaboration at scale. So we start with 2 organizations, maybe that's fine. We can handle maybe 2 organizations, request 3 organizations, 4, 5. There comes a point of working out how do you balance what is a reasonable request from an organization between what is good for a collaborative group as a whole. And again, this is another question that we're hoping to tackle with our projects. So I'd like to sort of thank you all for listening to this at the moment. And really, if you'd like to follow us on the journey of learning how we discover the answer to these questions, then drop us a follow on LinkedIn, or drop us an email on hello@raiven.xyz. But at the moment, and I'd like to open the floor to any questions that people might have.
Questions? One question? So with these federated
Yeah. So I mean, should probably go back to this sort of diagram and explain it a bit better. I think I rushed over it a little bit there. So I mean, normally what happens is you start with an initialized global model that you push to every device. Then each device, based on what they're seeing, will train on its own data. Then after each training step, it can push that data back up to be aggregated in the global model. And then that global model can be pushed back down, and you can repeat that process as much as you need to for training the global model. But then when it comes to fine tuning, at some point, once you're happy with your global model, you might distribute that back out to the devices and allow the devices to fine tune. And that's where in the centralized thing, we're tracking statistics about the models, individual devices at each level. So we can see how they're drifting from the global model. And that's when you can, at some point, you make a choice of going, well, is that drift too much? Is the accuracy decreasing? Do we redeploy the global model out? How do we drag it back to be more generalized? Sorry, what do you mean by learning from another model? Well, really, they're all really variations of the same model. So, I mean, if you'd look for federated learning, you would find this description of this architecture. So they're all, what you start with is a global model that is pushed out, and then there we go. That's the keyword. Hierarchical aggregation. That's the that's the keyword. So no, you're training it at this bottom level, at the individual site level. You're just aggregating it at the organizational level or at the top level. I mean, in some ways it adds some complexity, but in some ways it adds solutions as well. So like one of the problems with a centralized model is if your centralized model goes down, your entire infrastructure goes down. But in this situation, if one device goes down, most of the infrastructure stays up. But yeah, managing it is a difficult element of it, but it's not unsolvable, I guess is the point. I think in there is a progression in industry to more distributed computing, more devices, more data being collected on device. That causes a problem with all that data, particularly if you're starting to talk about video data or data that's high in volume. How do you serve all that and centralize it? That there doesn't really exist infrastructure that can handle at some point that high level of data, and it becomes very costly to transfer it. So really, it's a challenge, but it's also the only way of dealing with that demand for data.
So the microphone's not sensitive. Are there any ways of detecting data with some of the devices that have bad data to their version of the model, or some of the devices that have
Yeah, I mean, as far as I understand, there's a lot of exploration on this, and there's some very nice sounding keywords that I can ask George for. But like, largely, you can when you've segmented it to different devices, you can probably detect anomalies in your data as well. Like that's an extra bonus of this. You can start to see where things are differing from what you'd expect, and usually that will help you pinpoint things like that. But are there any other lovely keywords to mention around? Yeah, well, I mean, so obviously the Google example is one use case of it from the software side, and it is specific to a use case. In the case of, I have a keyboard. From us, this example is well, we're talking health and safety in sort of manufacturing logistics sites. So yeah, part of the problem is actually standardizing a problem. It's useful in this instance because we can have two organizations, and health and safety is very similar across any organization that's performing these activities. We're observing people driving forklift trucks and vehicles around an area, people lifting and moving around an area. So because of that, like the use cases are the same, which makes it easy to say, well, actually, if we can standardize the data that we put in, we can make this into one centralized model that can benefit multiple organizations.
So,
yeah, so I mean, as far as I understand, there are ways to actually query the data. It is possible in some methods of federated learning, but in the approach we're taking, probably not. What we do have is the summary statistics of the data, and in many ways, in your data science training process, the first step you're doing when you're doing your data exploration, most of the time, what you're doing is looking for potential features by saying, well, what is the spread of this data? What is the distribution of this data? What is the, like that sort of example, right? So with that in mind, we don't necessarily have to see the data if we can see the summary of it, so we can understand what each variable is actually talking about, like as in what it looks like as a variable. Is it useful as a predictor as well? So if we can tell that from the summary statistics, we don't have to see it. But synthetic data is actually one of the steps that we're considering as a, if we can't do it just from that, well, yeah, maybe we do need to generate some synthetic data from it to keep this philosophy of privacy, and we have to work out then how do we generate believable synthetic data from it.
Thank you very much.